Hey guys, hi, hello everybody, a very warm welcome to your today's chemistry session in which we are going to discuss the interconversion of states of matter with effect of the pressure. Okay, so in the last session we discussed the temperature effect, and in this class we'll be talking about pressure, a very important session for all of you. So make sure that you attend the entire session, and if you are new on the channel, then you know what you have to do. Cation Army is going to subscribe to the channel and hit the like button of the video. Also share it with your friend, so that like at least one friend you can share the video with, so that you know they can get to know there's a channel on which they are covering the syllabus of 9th and 10th in English language. So the mode of communication is going to be English for students who don't understand Hindi completely. Okay, that is the main agenda, and we are discussing everything here. Now who am I? Because this is a new academic year, so a lot of you won't be knowing me. So I will be your chemistry master teacher here on this channel. Okay, and together we have to make sure that our journey is fun as well as interesting, along with covering all the important topics in the as easiest way possible. Okay, and we always start with cationic vibes around in our session. So for the same reason, for my cation army, there is an awesome blossom coach that you can see on your screen. If you are positive, you will see opportunities instead of the obstacles. Right, so you have to stay cationic. है ना? Positive here is not the COVID positive, it is about the optimism. So if you inculcate a habit of seeing the good in every bad situation, the positive in every negative situation, then we will be seeing that the obstacles that we feel are actually opportunities for us to grow, isn't it? So no matter what, always stay cationic. And let's get started with the fourth session of our chapter number 1, interconversion with effect of the change of the pressure. So stay till the end. First of all, we are going to do a quick recap, then the effect of pressure, and how these interconversion can happen between these three states of matter. Okay, starting with a quick recap. So I discussed the effect of temperature, like you are having a solid substance. How can you convert a solid into a liquid? If you increase the temperature, isn't it? So when you are heating a solid, then that heat will be absorbed by the solid particles, and they will use that heat energy to convert themselves into a liquid. We talked about the concept of latent heat, what is a melting point, then the reverse may we also saw what is freezing point. So again, if you are taking a liquid, if you decrease the temperature, you are going to get back the solid. What do we call these processes? All that we saw. Similarly, liquid to vapor conversion, if we are increasing the temperature, that means we give heat energy to liquid, they will be using that heat energy and finally be a vapor. And on decreasing the temperature, you can reverse the change. So again, here also we discussed the latent heat of vaporization. So what is simply a latent heat? That means the hidden heat in the system that is used to convert the state of matter at a constant temperature at atmospheric pressure, right? So you know that whenever state of matter is changing, temperature will always be constant. Why? Because all the heat is being absorbed by the particles to overcome their force of attraction and finally become a liquid, or we can say vapor. So all that we saw in the concept of latent heat, so that was very important. Now we are starting with a new topic. Can increasing or decreasing the pressure change the state of matter? What do you think, guys? Give me the answers in the chat box. Is it possible? Yes, definitely it is possible. We can increase or decrease the pressure and we'll see, wow, the state of matter has changed. Now why is it so? Ma'am, how is it possible when we increase the pressure on a substance? its state is going to change. So see, when you are applying pressure on a system, let's say we are having a gas. Okay, so we know that in gases particles are far apart from each other. The forces of attractions are very weak, rather you can say negligible. So when on a gaseous system we are applying pressure, yes, so when we apply pressure on a gas, what will happen? Because particles have lots of spaces between them. On applying pressure, these particles are going to come close to each other. Yes or no? Tell ma'am. Definitely. So by applying pressure, particles can be brought closer and closer. Now if you do this thing with solids may, you know, they are already at the maximum closeness. Solids may particles are very tightly held to each other. So if you apply pressure on them, then there is no effect on the solids because they are already at the maximum closeness. So if you apply axis of pressure on a solid, it is going to break down. Like if I apply a lot of pressure on it, it will break. But if I have a gas, because particles have lots of spaces, so on applying pressure on a gas, the particles start coming close to each other, gases start compressing, and finally matter can change its state. That is why, remember, compressibility of gases was maximum, isn't it? Compressibility is highest in the case of the gases. What was compressibility? Reduction in volume on applying pressure. So why that volume is reducing? Because particles of gas start becoming close to each other. Okay, so how can we liquefy a gas? A very important question that can be asked in your exam. So it means we are having a gas. So what we want to do? We want to convert a gas into a liquid. Okay, how I see this? Gas may, we know particles are far away from each other. There are lots of spaces, minimum attractions. If I want to convert it to a liquid, that means liquid is the kind of system where I need to bring the particles closer. Yes, so if you compare gas to a liquid may particles are having less spaces between them. That means particle needs to come closer to each other. In gases, force of attractions are negligible, but in liquids, comparatively, force of attraction among the particles is stronger, isn't it? So this is what we want to do. We want to bring the particles close to each other. Also, we want attractions among the particles to increase. If this is going to happen, a gas will be converted to liquid. Yes or no? Tell me in the chat. Definitely. Okay, so what are we going to do here? The first thing that comes to our mind is to increase the pressure on a gas. Why to increase the pressure? Same thing, on applying pressure, the particles of gas will start coming close and close and close to each other, isn't it? This is going to happen. Dekho, these are the gas particles. I will apply pressure on them. So these particles will say, okay, pressure means the spaces are reducing. We will start coming close to each other. Yes, now one thing I want to tell you guys, please listen to ma'am very carefully. What we have done compression. I am compressing a gas. What is that compression? On applying pressure, the particles start coming close to each other. The volume reduction is happening. Hai na? The beauty is that whenever compression is going to happen, whenever you apply pressure on the particles, then you know particles, they get irritated. Particles be like, we were enjoying our space. This was a gas. Gas way particles were like, dude, we have so much of freedom. We are having so many spaces between us, so we are like kind of living in a free world. Now all of a sudden when you start applying pressure on a gas, particles become close to each other, they get irritated because they're like, we don't know what is closeness. So when you bring particles close to each other, so what happens, there will be some collisions among them also, and during the system these particles will be releasing some heat energy. Okay, some of the heat energy is being released when you are doing the compression. Okay, particles release the heat energy. Now release the heat energy means the temperature is going to increase automatically. Yes, whenever you are compressing a gas, when you bring particles close to each other, the temperature automatically increases. But understand the point. If temperature will increase, then what will happen? Temperature increase means kinetic energy is going to increase. Particles will start going far away from each other. The speed is going to increase. Particles will again, kinetic energy of gases is higher than the liquids. So this is a anti-process than what we were trying to do, because liquids have less kinetic energy, gases have more kinetic energy. So when you are trying to convert a gas to a liquid and in the process kinetic energy of particles increases, they will again start converting into a gas, isn't it? They will say, okay, we are going far away. So that is why the process of compression is incomplete without controlling the temperature. What you need to do here, you have to simultaneously decrease the temperature as well. Okay, so what needs to be done here, beta? We are increasing the pressure, along with that temperature should be decreased. Why temperature should be decreased? So that the gas particles can lose their kinetic energy. Decreased temperature means kinetic energy of gaseous particles will decrease. They will start slowing down and finally become a liquid. So how can we liquefy a gas? By applying pressure and reducing the temperature, we can liquefy the gases. Okay, remember this point. That is why if you ever see the liquefaction process of the gas, you will always see a compression tank. The first you will see that there is a compression tank. In this compression tank, we are increasing the pressure, bringing the gas molecules closer to each other. Then just after it, you will be seeing a cooling tank. Okay, so that cooling tank is used for decreasing the temperature, ताकि particles lose the kinetic energy, and then you would be getting the liquefied gas. Fine. And the reverse process can also take place, like if you are increasing the temperature, you reduce the pressure on liquid, they will give you a gas again. Okay, so that is what we will see now, that yes, pressure can convert the state of matter. For example, you know about carbon dioxide gas. Yes, if we are going to apply pressure on the carbon dioxide gas, it can also give a solid directly. Okay, few gases have this tendency that when you apply high pressure on them, they would be giving you a solid state directly. So this is your hard ice, or you can say dry ice. You have seen it on the birthday parties, annual functions, in stage performances, whenever there's an entry of any hero or a dance group, so you can see a lot of smoky appearance at the bottom of the stage. So what is that? They store carbon dioxide in the solid state, and then they reduce the pressure on it, it again becomes a gas. Okay, so you can do this interconversion of the state of matter using pressure, and it has a lot of applications. If you take this solid carbon dioxide known as dry ice, it is stored under high pressure. This is what ma'am was saying. Okay, and if you reduce the pressure on it, when you whatever you have stored, ये जो dry ice you have stored, जो आपने store किया है, if you are going to reduce the pressure on it, it will again give you carbon dioxide gas. Okay, so you can see the conversion of solid to the vapors directly, that is sublimation, isn't it? So it's the same process. If you are increasing pressure on gas CO2, you are getting the solid CO2. If you decrease the pressure on this dry ice, it will give you CO2 gaseous state again. Okay, that is what they do in the stage performances also. You can see this kind of smoky appearance come, that is actually CO2. Okay, yes, carbon dioxide होता है. So you can say solid carbon dioxide gets converted directly to gaseous state when you are decreasing the pressure to 1 atmosphere. And the reverse of it happens if you want to convert gas to a solid, तब भी इतना high pressure you have to apply, okay, without coming to the liquid state. Similar kind of phenomena you see in your LPG gas cylinders also. So this is your homework. Tell me, LPG gas cylinders work on which principle? They are also using pressure. Yes. Okay, so you know that whenever you have your gas cylinders, if you ever shake slightly, you tilt them and try to shake it. So in those gas cylinders, you can feel there is a liquid. Okay, so you have liquid butane and liquid propane that you can find inside the cylinders. Okay, so it's a mixture of propane and butane. So what do? These gases are converted to liquids actually. Okay, they convert these gases to liquid. So there is a liquefaction of gas that we do by increasing the pressure and decreasing the temperature. Fine. Now why do they do this? Why liquefaction of gases is done? Because you know gas ka transportation is difficult. Gases require very large containers to be stored in. So to avoid that problem, to make the transportation easier, to use the small containers, we can fit large volume of gas in the small cylinder by compressing it, by liquefying it. Okay, then this liquid fuel is filled in your gas cylinders, and there is a, you can see at the top there is a knob also, है ना, regulator kind of thing. So when you are connecting it to a gas, when you turn on your gas, this liquid is again converted to gas because pressure is reduced and the fuel comes out as a gas finally. Okay, so write it in the comment section how LPG cylinders are going to work. So this is how we can bring about the interconversion of state of matter. So this table is on your screen. We have done all these processes. So I hope you know that the name of all these processes, है ना? So we are having solid, we are having liquid, and this is our gas. Conversion of solid to gas directly, sublimation. Gas to solid back, the process is deposition. Okay, so these are the two new terms. Baki all we have done already. So remember to revise your notes. And there is one thing that ma'am wants to tell all of you about. That's about the Vedantu Pro Light subscription of class 9th. So the students who were connected with us last year, they all have banked in their class 9th, okay, with very good academic record. They are in the 10th class now. More important than that, their basics are all clear. Okay, so 10th mein, you know, it's very important, and this time there is a reduction in syllabus. So those topics like mole concept, you should know them. Okay, so come with us in the journey. We give you a lot of offerings also. We also have courses to cover the reduced syllabus, okay, via the micros. You would be getting the live in class doubt solving. What are the features? Ma'am will start telling all of you about it. So what you need to do, first of all, the video that you are seeing right now, है ना, अभी जो आप वीडियो देख रहे हो, you have to go in description of that video. एक लिंक आपको मिलेगा, that is about the Pro Light subscription. ठीक है, this one ma'am has highlighted it. We will tap on that Pro Light subscription. So the best part I will tell you, if you want to be connected with us in the academic journey, so Vedantu YouTube master teachers are also taking these batches. And YouTube teachers you will get in the beginning wale first few batches, ठीक है. So if you want to be in Abhishek sir's batch, in Shilpi ma'am's batch, in Harsh Priyam sir's batch, best time to grab it. Okay, so what you have to do, beta, this is the site that will be open from that link. Everything is written here. We are giving you VIP also, that is Vedantu's improvement promise. By the end of 1 year, if you feel that you haven't improved in your academic marks, Vedantu promises to give you your fees back. Isn't it amazing? It is. Okay, so what are the subjects that we are providing you? We have maths, physics, chemistry, biology, English and social studies. A total of 6 subjects will be covered in the subscription. The fees is on the top, 4,500 for 1 year. You heard that right. The prices are super low. And guys, please remember, prices are going to increase from next week. Okay, and they will be increasing. Note it down, grab this right now. If you are seeing this video, do not give a second thought. 4,500 rupees, 1 year, 6 subjects, awesome master teachers, world's best teachers are going to teach you. Okay, and your result, your basic clearance, everything is guaranteed. You are getting a test series throughout the year with this. A test series, mock test paper series. You are getting the mid-term revision, you get end-term revision. You can access the crash courses also. Everything would be like coming as an add-on. Are you understanding? You don't have to pay anything separately for that. And during the live classes, all your doubts would be resolved. So scroll down, all the features, the live notes you would be getting, handwritten notes by the teachers, PDF ho sakta hai, unlimited replays are available. Okay, so 1 year 4,500, but with Shilpi ma'am's coupon code. What is Shilpi ma'am's coupon code? You know, that is SKA Pro. Shilpi Kaushik Army Pro. Okay, apply this, you will get it for 4,500, varna 5,000 ka hai abhi. 4,500 mein you are getting this entire complete subscription for 1 year. Every penny is worth taking it over. Okay, so please remember, note down the coupon code. Come, I want to see you there. Okay, you will be a pro member and getting the best services ever. Now this homework question, what is the physical state of water at 200 degrees Celsius and 10 degrees Celsius? Comment section. Next time I will be attaching the name of homework rock stars in the session. Okay, this is Shilpi ma'am's Instagram. You can follow me there. I am Kitain is my ID and you are the Kitain army. Okay, make sure that you hit the like button of the video. I'll see you next time. Take care and stay hydrated. See ya.